Hello, everyone. Welcome, welcome, welcome. I'm Quinn. I'm a coach at MLH. Welcome to this stream. We're going to be building a data pipeline. I hope you've all been having a great Global Hack Week so far. For those of you who've been to any streams, please do tell me which ones you've been loving. I'd love to go back and watch some as well. So tell me your favorites so far. Before we jump into things, I'm going to give us a couple of minutes for people to join. I'm also going to let anyone who's stuck in the Twitch ads to get through. So we'll give it a couple of minutes. In the meantime, please do check in. I'm going to put the check-in link in the chats. There we go. All right, I'll throw that up on the screen as well. By checking in, you get extra swag, and we love extra swag. So definitely do that. You also get points, and who doesn't love having more points than everyone else? I love collecting points. Do recommend. But yeah, please tell me where you're tuning in from, what your favorite stream so far has been, and we'll get started in just a couple of minutes. Hello from Houston. Awesome. Welcome, welcome. Cool. I'm going to throw on some gentle music in the background. Maybe we'll get some like kind of lo-fi coming in. Tell me if it's too loud or too quiet. Hello from India. Welcome, welcome everyone. Cool. All right. So, for anyone who's like, oh, why is Quinn looking off like this way? Can you see like this way all the time? I've got a second screen with all of the chat and things up on. So don't worry. If I'm seemingly looking away, I'm actually paying extra attention to you all. Welcome, someone joined from Rome, Italy. That's super cool. Yeah, okay, so maybe we'll kind of slowly get started. I'm going to share my screen, so hopefully you can all see this. And cool, okay, so today we're going to be building a little command line interface tool, or CLI tool, which is going to load in data and allow us to investigate it, allow us to transform it to our needs. And in particular, the data sets that we're going to be looking at are from a company called Epoch AI. They do a lot of evaluation of generative AI models. So we're going to be looking at data sets of results and benchmarks of different AI models and how we can kind of combine them together and use them. And we're just really looking at that first section, so like the combining, maybe a little bit of investigation on the formats of the data that we have, and how we can match up models across different data sets as well. So we're going to be doing some kind of matching and data cleaning in there too, which should be pretty fun. And along the way, we're going to learn how to build the CLI tool using Python. In terms of like prerequisites for this stream, pretty much just basic knowledge of Python will be fine. We'll kind of get into everything. Yeah, everything more advanced than just basic Python will be explained, so should be good. Yeah, but before kind of we do anything crazy with data in terms of analysis, and I'm sure some people will be showing you some really cool like, visualization analysis type stuff this week. We kind of need to have it in a usable and clean format. We need it to be in the format that we need. And if you don't do a good job of cleaning or pre-processing your data, it's going to limit the impact or possibly the accuracy of the analysis. So this is maybe a more boring area of data science, but I think a pretty important one. Cool. Okay, so let's talk about the data that we're using and where we're going to get it from. So I'm going to open up a new window in Chrome. I'll just put it on over here. I'm going to head over to Epoch AI Data. So if you Google this as well, you can head along to their website. See if we can find it. Okay, I'm going to head to the Data and Resources tab. I'll drop the links in. I'm going to go to benchmarking. And so this is the kind of data that we're interested in. We're not actually going to be using their own index. We're going to be using all of these different benchmarks. And so you can see here, there are like a whole load of different benchmarks. We've got some developed by model developers, we've got creators benchmarks, we've got some that Epoch AI, this organization, maintain themselves. And so there's a whole load of them. There's probably about 40 here, I think. And we can actually download all of this data. So you can see here that we can turn these on and off in their charts. And that's all well and good. But it's locking me out. It's not saying I can do anymore. That's okay. It's all well and good. They've got this beautiful plot, but maybe we want to do something else with the data. raw data itself. Maybe we wanted to build a model to predict how these model performances would change over time. Well, that is something that we could do, but we need the raw data. And so we can grab it from this tab here, and we can download it. Now, if you're going to publish this, make sure to pay attention to their licensing. So we can just give it a read here, but basically we're allowed to do it, use it, as long as we kind of give appropriate reference to the organization. So thank you, Epoch AI, for allowing us to download this data. So I'm going to click download, and I'll pop this link in the chat as well. Cool. And the other bit of data that we're going to want is we're going to want model data. And I'll show you why in a second. So we've got all of these different models. We can select just frontier models, or we can just have all of the models, which is, you know, a lot, especially going back in time. They've got the training compute used here as well. So there's some useful data, which we probably won't have time to get into too much. But we're going to use some of it, so let's download this too. Alright, and I'll pop that in the chat as well. Perfect. Okay. Alright. Now, I think we're pretty much done with the internet, so we'll get straight into things. What I want to do first is I want to set up a project, so I'm going to create a new folder, and I'm going to call it, not in here though, let's do it in my actual project. So, I'm going to call it Epoch Data Pipeline, and we'll select this folder. For anyone not familiar with what I'm using, this is VS Code, and you can create your own folder by clicking open folder and then make a new one yourself in your own directory. Cool. Okay, so this is great. Let's, before we really get into anything, make a data folder. Data, and let's grab our data and pop it in here. So I'm going to just drag it across from another screen. Actually, yeah, this is okay. Give me just 1 second. Okay, cool. You can see I've downloaded some of the bits and pieces already. Or not, it won't let me. Okay, there we go. All right, so you can see I've downloaded it twice today. That's okay. So we've got the AI models and the benchmark data, and they're zipped. But that is 100% okay, and I've actually already extracted them, so you should do this as well. And we're going to open up this benchmark data folder, and we're just going to grab everything in here. We don't really want the ECI data. This is not something that we're interested in for now, but they wrote a very interesting paper. If you were interested in reading it, I'd recommend. So I'm going to copy all of this. I'm going to pop it here. Great. Cool. So that is not in our data folder. Oops. We'll remove it. Okay, so we've got 45 data sets because we've got the README. This has just got the details on licensing and citation. We can leave that in there, that's no problem. And if we look at some of this data, you can see some of it looks like a little messy. We've got like training compute notes. Lots of this information is like not what we're going to be interested in pulling out. Because what I'm interested in doing right now, and this is kind of for demonstration purposes for this workshop, is each of these benchmarks has the model, right? So, for example, Claude Opus 4.6 Max, and it's got scores. So it's got the best score that this model got on this benchmark, which is a maths benchmark, and it's got the mean score, it's got some other information, but generally we've got the model and we've got the score. And what we're going to be doing in this workshop is building a tool that we can use to extract the models and scores from all of these different data sets, no matter what the format of the data set is, and match them up. And that way we would have a nice clean bit of data that we can use to do more analysis. So we will pretty much get right into that. Are there any questions? Oh, someone wants a recap. So yeah, so anyone who's just joined, we're building a data pipeline tool using the command line interface. We've grabbed some data from the links earlier on in the chat. Hope you can see them. If you can't, let me know, I'll resend them. But we've got a whole load of data, and we're going to be cleaning it and tidying it as automatically as possible. We don't want to do loads of manual cleaning. Like if I was going through here and just like deleting bits that we don't want, it would take forever. And you could, try and do it in Excel or something, but it would be a miserable time. So we're going to build a tool to do it for us. So we've got our data in a project folder within the data folder as well. And then also we are going to need the AI models data, and we're just going to grab all the AI models, not any particular ones. We're just going to grab as many as we can, and I'll copy that in here as well. Okay, and you can see again, this is like a very messy file. It's pretty ginormous. How long is it? It's 23,000-ish lines long, and just pluck some in the middle. We can see in the gray we've got Gemini 2 Pro, for instance, and the domain is it's a language multimodal vision video and audio model. We've got a description of the tasks that it's developed for, the organization that developed it, the authors, so in this case the Gemini team. We've got the publication date. We've got a reference, which just seems to be a comment from the author. We've got a link, we've got some citations potentially, although that's missing here. We've got a whole bunch of information on these models, but the most important thing is that we've got a list of names of all the models, right? So we've got GigaChat Lite. I haven't heard of that before, but this is a model that exists, right? And so there are loads of them in here. And what we're going to be doing is we're going to be saying, right, we've got all of these different models in here, which might well have different names. Let's match them up across our datasets to our models, CSV. Which sounds simple in theory, but actually might end up being a bit messy because the data is not always clean, and matching names can be tricky because they've got lots of things like this, where this model is similar to this model, right? Claude Opus 4.5, but they've got different thinking budgets, right? So that's going to be something we're going to have to overcome. So, for instance, here we have the same thing with GPT-5. We've got lots of similar but different versions. We got O3 Pro and a normal O3. We've got different release dates. There's all sorts of things that are going to be hard to match across. Okay, but this I think is probably the example data set that we're going to use throughout when we're testing. So kind of just have a little scan of this. We've got our scores column, which is helpfully labeled score, but it wouldn't always be. We can have a little scan. Yeah, look, in MMLU, which is a very famous benchmark as well for models, it's got EM instead of the score. And we could double check exactly what that stands for. I'm not actually sure off the top of my head what it stands for, but this definitely looks like the scoring column to me. Cool. Okay, so great. We've got our data. We're going to try and match our data on. And the goal in my head is to try and build this kind of long CSV where we've got rows of models, the scores that they got, and the benchmark that they got it on. And this way, all of our data is in one place. It's nice and neat and tidy, and it's standardized. Okay? All right. Cool. In terms of what we're going to be using, we're using Python. Pretty standard stuff. And I'm going to open a terminal, and we're going to create a virtual environment and get straight onto it. So hopefully that recap and summary of what we're going to do makes a lot of sense to you all. Let's get into it. So I'm going to first make a virtual environment, and I'm going to do it with a little name. I'll give that a second so you can see my virtual environment has popped up here. For what it's worth, I think Epoch do actually have their own tool to handle their data, so this is already done behind the scenes. And if we look carefully at this data set, I think they might have an ID, but they might not. There's probably an ID that we can match on, but I think it's more fun to learn how to do this natural language string matching. So we'll do some of that. But we can maybe check the quality of our matches if we do have an ID. Yeah, so we've got an ID here in each of these, I believe. Yeah, ID. So these probably match up across data sets, I would hope. Yeah, Yet again, we've got an ID. So these should match up, but we're going to build our own tool to do this, even though Epoch AI have their own tool. Because it's fun to build our own things, and it means we learn, and also it means we can use it on data that isn't just from Epoch, right? This will work across any dataset source. So we've got a virtual environment, and I'm just going to activate it like this. You can do this on your own device. You probably... It may or may not work, depending on whether you are in Windows or Linux or Mac, and then also depending on your terminal. I'm going to switch to not Bash. I don't want a Bash terminal. I'm going to switch to the PowerShell. Yes, there we go. I'm going to have a PowerShell terminal. This is the default on Windows, so anyone who's following along on Windows will have a more normal time. And you can see it's actually already activated my environment for me, data ingester. So that's great. And now we're going to have to do some installation. So we'll pip install, we want pandas, we want rich, we want PyArrow. And these are going to be used for handling our data, basically. Rich is used for output, terminal output. Pandas you're probably familiar with. If you've been to your streams this week, you definitely will be. It's used for handling data frames, which are a way of structuring our data when we interact with it in Python. So we can pull a CSV into a data frame, and it's just a neat and convenient way of dealing with our data. While we're waiting for that to load, we will create a file, and we will call it epoch cli.py. Okay. And so this whole workshop, in theory, is going to all fit into this one little script. It's going to be this kind of catch-all command line tool that does everything we need. Awesome. So while our installations are happening, we can maybe get started. All right, installations are done. That's good. Cool. Okay, so to begin with, what I want to be doing is we're going to build just a very simple CLI tool that will allow us to just preview any CSV data. And that's not what I wanted. GitHub Copilot. It's getting too excited. Including within this preview, so this is going to be the first step. But including this in this preview, I want to be able to see the dataset shape, which is just the rows and columns, and the data types, and probably like a clear head table. And head is just the start of the dataset. Yeah, preview. That's great. Okay. Cool. So we're going to do a few imports here, which are going to make our lives easier, and they will all become clear as we use them. Need a new line there. I'm going to import pathlib from pathlib import path, which is going to allow us to route ourselves to each of our data sets. We want pandas, and we import that as PD. And we want from rich console, we're going to import console. From rich table, we're going to import table. And from rich, we're going to import. Okay, cool. So rich, as I mentioned, is just going to make us allow us at least to have a nicer, kind of more satisfying, visually pleasing output in our terminal, which is going to be how we're going to interact with this tool. Cool, and we're going to have a global console through rich, and this is going to just allow us for prettier printing. Yes. Okay. So the first thing that we need to do is we've got some data and we've got it in CSV form. So we're going to want to read in our data. So let's make a level function that will do that for us. And we're going to have a path object. And we're going to output a data frame from pandas. Okay, and let's add a little doc string just describing what we're doing. Read a CSV file into a pandas data frame. Cool. And you might think this seems like a little unnecessary. Like, why are we building a whole function for this? Aren't there things that already exist? Like Copilot, for instance, is just like saying, "Oh, just return the function." And we're not actually going to exactly just return a function. We're going to do if not path.exists, and we're going to raise an error. So if we can't find our file, we will raise an error. And this is the kind of benefit of doing a standalone function for this. The benefit being, yay, if we have errors later on, it's hopefully going to be easier to work out where they're coming from. So it's a debugging tool, basically, is what I'm saying. For now, we're going to just assume like a standard comma-separated file, which is what we have. But if you wanted, you could change this or adapt this or whatever you wanted. You could have like a read-in file and just handle whatever the file is. That would also be a nice and flexible extension of this. And a good reason, again, to simply have it in a function, even though it's pretty much a one-liner. But that's okay. Cool. Okay. And we are now going to have a... yeah, this is what we want. We want df head table. All right, and so this is gonna convert the first n, so the first like 5, for instance, number of rows in a data frame into a rich table, one of these. And this is just for displaying purposes, so we don't need this for like processing the data, but it's going to allow us to visualize it more easily and comb through data quicker. And combing through data is sometimes boring and slow, so it's much more preferable to make it as fast as possible and also as easy and pleasant as possible. Okay. I don't know what your opinions are on data cleaning. Maybe you all love data cleaning, and I'm just like the only one who's data cleaning is the worst. But like, this is why we're building a tool, right? Because like data cleaning is boring, we can make it less boring or at least quicker. Okay, so we're going to convert the first n rows of a df into a rich table. You got a question? Will we have access to the code later? Struggling to keep up? Yeah, that's totally okay. Yes, I can throw this onto my GitHub and share the link. For now, I'm probably not going to do that, just so that encourages everyone to kind of code along. But maybe like in around like half an hour, I'll push it onto my GitHub, and so anyone who's a bit behind can catch up. I can also go a bit slower though, like that's 100% okay. I know it can be like tricky to follow along sometimes, so yeah. We'll also have like some pauses throughout while we chat about what we're doing. And also like at some points there might be like places where I have like bugs and stuff, right? Where we have to fix them live together, and so we'll have like time then to catch up to. So don't worry, we're not gonna fly away like the wind. It certainly won't get any quicker than this, and I expect like if we have any issues, it may even we might have a break later while we work out them. So, right, so we're going to create a table, and we're going to have a title, and the title will be like a preview first n rows. Yes, perfect. And then throw in a comma. We'll end the f string. For anyone who doesn't know what an f string is, it's a really neat way to create a string that includes variables and other bits and pieces. It's useful for things like titles and printouts and stuff. So it's a good thing to learn in Python if you're not familiar with f strings. Then we're going to make a box, and this is just a type of box. There are other types of box, but yeah, again, like you could Google these. This is just the one we're going to go for, and we're going to say show lines equals false. You can have a play around with this to make the box that you like the best, or rather the table that you like the best. We're going to create a header style as well, and we could have, yeah, why not, bold and magenta. Thank you, Copilot. Okay. Alright, so we've set out our table, and now we need to add one column to our table for each column that we have in our data frame. So we're going to go for column in our data frames columns, table.add column, and then we will put in the column. But actually, let's put in the string of the column, because you might have a column that's not a string by default, and we'll say overflow and fold it. Have a little look at all of the arguments that we've got here. We can choose to highlight the text. I mean, there's a whole load of options. We can choose the footer style. There's all of the different bits and pieces that you could possibly want. I do love Rich as a Python library. It's really great. Thoroughly recommend if you're not familiar with it. Let's say no wrap equals false. Okay. I think actually by default it's false, but we don't want it wrapping us around making this confusing for us. Okay. And we will grab the head, this data frame, up to n. So first n rows of the data frame, and then we will say for each yeah, okay. Oh, that's typoed. My bad. Is this actually what we want? No. Copilot predicting the wrong things. For each row in our head, so if we grab the first 5 rows, for each row in those 5 rows, we're going to grab our cells. So these are the actual, let's put an equals in there. These are what we're actually kind of adding in terms of the content, and so we'll grab from each row we'll grab the column, yes, like this, for C in df.columns. Nice, does that work? Be good if I could type columns. Okay, yeah. So what we're doing is we're basically grabbing, like, for every row, we're going through all of the columns and grabbing the values, and then we're putting them in a list, but we're making sure that they're strings before we put them in. So we've got a list of strings where each portion of the list is the column from that individual row. So essentially going through the rows and scanning left to right, if you like to imagine it that way, and grabbing out the strings. So we now got a list of strings in that row, and so we can just add rows. So table.add row, and yeah, just like that. Perfect. Okay. And then we can return the table. Cool. Okay. So now we're going to create a command that we can use with this script. And this command is going to be the preview command, which is going to allow us to see, basically do all of this, right? We're going to preview our CSV data. And so this is going to be for like when we've got new data, we're like, oh, we'll have a little look at it before I start cleaning it and processing it. I want to do that in a super quick way. How are we going to do that? Right. Well, let's build a command within our scripts. And so there's some arguments that we throw into it, like this. And it's going to output an integer, I think. Yeah, I mean, we could output nothing here. Like, the function of this command is actually just going to be like print a whole load of stuff. But for testing, let's output an integer, return an integer. Actually, don't think it matters. We can do whatever. We'll go with this for now. No, ignore that. That error will go away. Okay. So what we're going to be doing here is we're going to load the CSV. We're going to print the basic info, and then we'll like show the table. Show. Yeah, and then we'll like just show tables because we might show a few of them. Okay, so let's grab CSV path first. This is going to be needed to load our CSV. We know that because we just made a read CSV function, and we're going to grab a path from our arguments, which will be put in when we type in down here. We're going to run like Python epoch CLI.py, and then we're going to have like some arguments in here. So like, for example, input. And after input, we're going to put in the path of the data that we want to load, right? And so input is going to be our CSV path, right? And then we will read in our CSV, perfect, and we're just going to read it into a data frame called df, okay? And then let's print some basic information, so like basic print basic info. Probably Copilot will help with this. Yeah, that's cool. We can print that. Yeah, we can do this. So for anyone who's not familiar with pandas, we can just grab out the shape of our data frame like this. We can also, if we want to, grab like, we could grab the number of rows with length, df, yes. And we could grab the number of columns. We could do it with length, df.columns, which df.columns just lists all the columns that we have. Either of these would work as well, or we could do df.shape and index on it, so like this, right? So these are like all ways of just grabbing up the shape, but naturally this is like the easiest one for us. So thanks to Copilot for that. And now let's build like a small table, and this is going to be just like describing the schema. So that's going to be the column names, data types, and we could add some other information here as well. But like for now, we'll go with that. So I'm going to call this just like the data type table, and it's going to be a table just like the others. This is a rich table. Title is going to be columns and data types, sure. And we'll go for let's just go for like a simple box, and we will say that the header style should be, let's go bold cyan. All right, and then that's done. Sure. And then we're going to want to add our columns. Great. We'll add our data type here, and that's not going to be like that. We'll just call it dtype. It's shorter, and then we will add table non-null count. Yes, perfect. That was exactly what I wanted. So thank you. I don't really want it in yellow though, so we'll get rid of that. Not sure about yellow personally. Okay, and then we're going to do a similar thing that we did in our building of our head table up here. We could actually separate this out into a different function as well, but I kind of think this is fine, so we'll just go to this. And we will pull out the full column by indexing on it. Yes, and then we will say that the type table, we're going to add a row, and yes, we're going to add the column name, column data type, and the count, which is non-null. Now I'm not sure if this is how. Oh, I learned something new. I was going to say we should do this by doing like col.not.na.sum, but this looks way cleaner, so we'll go with just .count. But this is like an alternative way of doing it. Okay. Neat. We'll check that actually works in a bit. Yeah. Maybe the only downside of doing this is like... No, I think this is fine actually. I think this is completely fine. Yeah. I think if we did this... No, I think this is good. It's good. Just like debating whether this is going to be exactly what we want, but it is. I'm fairly confident. So, and then we will print out our table with, again, just console.print. Nice and easy. And then we're also going to console.print and just nothing. Ooh, thanks Copilot for that one. And that's just gonna like print a blank line. So we'll just space things out a little bit. And then we can console.print as well. And we're just gonna use our df head table. And we could just set it n equals 8, but actually let's make this an argument as well. Why not? I don't think we would really use this argument. We'd probably just set the default we like and just gonna stick with it. But if we wanted to, for whatever reason, see a bit more of our data, we could. We're going to return 0 because we're returning an integer. Again, I think we could just return nothing here. I think that would be fine. Yeah, but that's okay. Okay, and the next thing that we need, because we've mentioned like all of these arguments that we've got, right? But we need to actually pass them. So we're going to have a parser, which will output an argument parser. Okay. So, oh, got some messages in the chat. No problem at all. No issue. Hello 404, welcome to the stream. We're building a data pipeline. You should code along with us. 404, for anyone who hasn't met, 404 is a cornerstone, I would say, of the MLH hacker community. Someone who I've recently seen as a hackathons in person as well, which has been really cool. And also has done a few streams themselves at Global Hack Weeks, so definitely go back in time and check those out on YouTube. Welcome 404, welcome to the stream. Okay, yes, we're building an argument parser here, and we're going to use like a bit of a kind of like a sub command structure. So like if you think about like git, for instance, right, like we can do like git status, we can do like git commits, right? We're going to have like a similar structure here. So for now, we're going to have like our file name is going to be like we're going to have like Python epoch cli.py. We're going to have like preview. But we could also have like Python epoch. Oh, I didn't mean why. There we go. Python epoch cli.py, and we could have like whatever else we like ingest to ingest our data, or like select. Right, there's loads of different things we can get out there. But for now, we're building preview. I'm actually going to delete this doc strings. It's just like, not very clear or helpful. And we don't really need one for this. I think it's going to kind of just make sense. It's just one of those bits and pieces which you just kind of need. Oops, what's gone on here? Let's not have that in there. Okay, and we're gonna have argument parser. All right, we're gonna give it a name, and yeah, I probably wouldn't recommend calling it epoch. What's up with this? If you're like going to be using other data sets, you could have picked your own data set by now, by the way, instead of the ones that I'm using. This will still all work, hopefully. Yeah, I'm going to call it epoch because it's just for epoch data. Cool. And we're also going to have some sub-parsers. And these are going to be for the different commands that we add. So we're going to add some sub-parsers. And this is just going to be commands. And we're going to say that it's required. Yes, very much so required, because otherwise who knows what we're doing. And so let's have the preview command. I'm going to add a preview command now. So this is the parser for previewing, so we call it pprev, and we're going to add parser. Yep, help preview a CSV data set. Yeah, that's fine. Okay, and then we're going to add an argument. We're going to need input. Yep, perfect. I'm going to have it like that, just so it's clearer when we're typing it out. That is the path. And we're going to have... I don't know why my indentation is going so wrong this time. Like, what's up with this? Yeah. I think Copilot is just like destroying things. If in doubt, blame Copilot. Yeah, we can go with the default rate. That's okay. And then we can just return the parser. Okay, cool. So we've got a parser. We've added some sub-parsers which have different commands. And the first one, well, the only one actually that we've added is the preview command. Okay, cool. And now we're pretty much there. We've kind of got something which should run. So let's finish off what we've got. Okay, so this is kind of the entry point for our tool. So what do we need to do here? Well, we've got to build our parser, right? Build parser, and we've got to grab out our arguments. If the argument dot command, i.e. what we set up here, is preview, then we will return command preview, and we'll throw in the args. And this is what we've built so far. Otherwise, we're going to throw an error. Actually, we're going to not just like else throw an error, we're just going to throw an error. And like this, it's going to be a runtime error actually. Runtime error, there we go. This should never happen because the command is required. But just in case, it's going to handle our errors nicely. So if someone puts in like a command that we don't recognize, it's okay. And then we will run it. Cool. So let's give it a go. All right. Are there any questions? Going to see me next week as well? Yes, I will be at Hack London for anyone who is based in the UK or even Europe. Hack London's going to be super cool. Very excited. I'm going to be there on Saturday and Sunday this weekend. It's going to be good. I'm guessing that's where you mean, Foreful. But that will be super fun. I'm very excited. Argparse is just what allows us to handle arguments that we're going to put into our terminal here. So, like input, for instance, or whatever else. Basically, it's just allowing us to read this, like, essentially just like straight line thrown down. Hopefully that makes sense. Okay, right. So, let's give it a go. So, I'm going to collect our data, and we're just going to pick one. So the input is going to be data slash, and we're going to use arcagi external.csv. And then we've got a default on head. I'm just not going to bother changing it. So we're going to run it. And let's pull this up. Oh, okay. So all of that, which I was saying, like, oh, we should make sure that we put in an actual command, right? We're requiring a command. Yep, I didn't put in a command. So there we go. Okay, much better, much better. Right. So we run our little preview command on this data set here, which is one of the ones that we were looking through earlier. And you can see like this is messy and ugly and impossible to read. And this is much nicer. So let's have a look. We've got 62 rows and 12 columns. And we can see that within those columns, we've got model version, we've got score, we've got the release date, and we can see that score is float 64. So even without looking at the data, we'd be able to say, okay, score is going to be the actual kind of key benchmark data that we're grabbing out here. The only other one that could be relevant would be float 64. The other float 64, which is the training compute in flops, which you might also want to use, right? But like, I think generally the other data is not going to be so useful if we're kind of imagining this tool to like extract just scores of like models' performances, right? So like the rest of this is like not super relevant. We've got the model version and the name. Like these, this is interesting. Like what could these be? We'd think like maybe the name is going to be like a generic name, and then model version is going to be more specific. So we might be starting to think, okay, if we're going to be matching our models across benchmarks, we're going to be wanting to use like model version over name in this instance. And we can see that in model version we've got 60 non-null cells, but we've got 62 rows. So that means that we're missing 2 model versions, but we've got 62 names. So maybe name is like more complete, but the model version is more accurate, so we could kind of prefer that. Otherwise, fall back to name. That seems like a good idea. And let's have a little look. I'm like super confused why this has happened. But what? Okay, so this is bugged. Let's run it again. That looks like a Visual Studio. Yeah. This is okay. The code is fine. I don't know what happened to VS Code. Okay, cool. So we can look at the start, right? And this is again much easier to read than this. So we can see our organization, Anthropic. We've got Claude Opus 4.6, and we've got the score that it got, which is 0.94 even. Very impressive. We can have a little scroll. We can see some other Claude models. So these are like much more interpretable names. And this is kind of like maybe a more technical name that's maybe more specific, although actually like looking at this does seem to be the similar level of like specificity, but we've got different like dates on them maybe. So maybe we do want to prefer model version overall. We've got some source links and other stuff, so this is like useful. And you can start to see like, oh, okay, we can start thinking about like how we can match these model versions onto our kind of central model database here, where if we search up like Claude, okay, so we've got a Claude Opus 4.5. Like, that's actually like really unhelpful now that we think about it, because like Claude Opus 4.5 here and Claude Opus 4.5 here, are they the same? Oh, they are the same. We have duplicate. Oh no, this is just the bug version. This is the bug version. I was like, wait, we got duplicates? Okay, no. Oh, maybe we do have duplicates. This is the same as well. Wait, let's make this bigger. Oh, we might have to handle right. Okay, so my VS Code is like, is cooked. I don't know why we're having so much. So this is like a visual bug with my VS Code and not a problem with our code. Like, look at this. Look at this. What is that? Okay, right. We're gonna just like kill this. I'm gonna just make a new terminal because I don't want to be dealing with that. Actually, we could use Bash. Do we think Bash will work better, everyone? Historically, a Bash fan. Let's give it a go. Actually, can I know? Python epoch CLI, and then we've got preview, and then our input is going to be, what was it? Data arc AGI external, right? I think that is it. Data AGI external. Oh, that's not what I meant to do. .csv. Lol, what? Okay. That's fine. It's unhappy with me, but it's working. Okay, right. Where were we? Okay. Cool. Okay, so what was I saying? We've got Claude Opus 4.5 with different thinking budgets. And when we look at our kind of all model CSV, we've got Claude Opus 4.5. Does it state the thinking budget? No. Okay. So we might actually have to build like a different canonical, like our own database, which has like different aliases. This is like the root model, but we don't have different thinking budgets on it, which is a bit annoying because it would be nice to match up directly to this. Okay, this is a design limitation of Epoch's model CSV. Feedback for Epoch. I think it would be good to have a list within each of the models that they have of like, I guess not actually, because you could just like arbitrarily set the thinking budget. Yeah. But for our case, because we've got different thinking budgets on our models, and that's going to affect the performance on these benchmarks, we're going to want to like differentiate that clearly. Again, this is bugged. Like, what is wrong with my VS Code? Okay, this is just going to be a problem we're going to have to deal with. Unlucky. I'm going to update my VS Code after the workshop. In fact, we might take a 10-minute break in maybe 10 or so minutes, and I'll fix that while we're gone. Okay, but for now, we have built a functional command line interface tool, and it previews the data for us, which is nice and good. So happy days. That's kind of like the first big thing done. Just seeing if we have any questions. Used to live in Sheffield. Hope you'll go to Hack London one day. Yeah, you should make it over to Hack London if you can at some point. It should be really fun. I mean, Sheffield have their own hackathon as well. Hack Sheffield happens in kind of like mid-late November time. Do recommend. It's good time. It's good fun. Yeah. Okay. Right. Okay, just having a little scan. Don't have any more questions, so I think we'll kind of just go straight into things. I don't think there's anything that I've kind of really missed. I don't think we've got any major questions either, so I think we'll kind of just go for it. All right, so the next thing that we want to do is let's build a selection tool that allows us to select the columns that we care about to keep, because there are going to be columns that we don't care about. And it would be cool to build like just a tool which allows us to see the columns, like some examples, and select the ones that we want. So, lots of like bugs in data pipelines come from like assumptions around the names of columns, and we don't really want to make major assumptions, especially if we want to have like really clean data. So this tool is going to kind of help us with that. Okay. Right, the first thing that I think we need to do is we want to be able to interact, not just print out stuff, but interact with our terminal. And so from rich, we're going to import, in fact, from rich.prompt in particular, we're going to import prompt and confirm, which allows us to do just that. Okay, cool. So prompt.ask allows us to ask like any kind of question to the user in the command line interface, and confirm.ask allows us to force like multiple choices, so we could have like a yes/no kind of prompt, and this is gonna make our tool an interactive tool without building like a full GUI. And I don't really like doing front end, so this is a win. This is a win for me. Okay, cool. So, excuse that, apologies. Cool. All right. Yeah, right. The next thing that we're going to want to build is a little catalog display. And this is going to allow us to like visualize all of the different columns. We're going to give them an index number for the user to select. They don't have to like type out long column names. It's going to give like the data types, like how much information is missing. So similar to our preview, it's also going to give like some example values, some like min-max values and stuff like that. So this is kind of like building on what we've done already. And we're going to need a helper function for this. So let's design that. So it's going to be called define column catalog table. And we're going to take a data frame. Nope, actually that's not what we want. I'm just kind of like mindlessly typing what Copilot is saying, which is like terrible thing to do. We're going to have like a maximum number of examples that we're going to like output in columns, and we're going to default to like 3, I think, because sometimes like the examples can get quite long. And then yes, we are going to return a table. Well done, Copilot. Well done, Copilot. Actually, okay. No, Copilot is just like way off with this. I was just say like maybe Copilot can help us type things quicker, but like it's not gonna do it. Okay, so table is gonna be table. I'm gonna just if you can give me actually maybe we'll, now that we're starting a new section, we'll give it a pause. I need to fix my notifications because things are confusing. My apologies everyone. And also I want to fix like whatever this is. Like, what? Why are there so many duplicate rows? Maybe someone in the chat knows the answer to that question. I definitely don't. So, but it's probably just like a kind of update and forget about it type thing. The title is going to be column catalog, and yes, we're going to make yet another table, everyone, for visualization, and we will have a bold cyan header style again. Okay, and then we're going to, as normal, add some columns. So we're going to add first column, which is just going to be our index column. So we're just going to put a hashtag in there for like the index, and we'll just fire right. Yeah, we can have it in a dim style. That's fine by me. And then we will want. Didn't need to do that. There we go. Okay, I'm going to add a column called column. And we're going to add column data type, a non-null count again. Yes, we're going to have unique. I think we want a unique column in here as well. Let's just like set this up. It's just adding like the most deranged style choices everywhere. I might just like kind of delete some of these because it's going to look like really. We'll justify this right, but it is going to look like really, really confusing. We want the numbers justified to the right. And then, do we want this in dim? I don't think we do. We can have the column bolded, but like everything else dim is just going to be like messy. I might get rid of this as well. I get like such a perfectionist about like how neat my tables look. Right, this one is going to be examples. Yes, good job, Copilot. Okay. Yeah, okay, and maybe we want like an overflow in here because like the examples can be like quite long if you like have a little look at the data that we're dealing with. Like especially like the notes columns, like the training compute notes can be like a little longer. These are provided by Epoch themselves, I believe. So something to be aware of. Okay, for yeah. So again, we're going to kind of we're going to go through our columns, starting at the first column. Yeah. Okay. Starting at the first column. My bad. I'm like not very good at typing this evening. I've had a relatively long day, so my hands are just like not there, and my brain's not there either. If you can't tell already, that's sometimes just how it is. Sometimes how it is, everyone, and that's okay. It's okay to have a tired day. That's 100% all right. And the reason that we have mini events at Global Hack Week is when you're having a tired day and you want to give your brain a break, go to a mini event. And also for other things like meeting like people in the MLH community. It's always fun to have little breaks. Okay, so I'm just grabbing out. This is what I did. Like this is what I was going to do earlier. I'm just going to like default it to it. I think this is fine. Like we could use the dot count again. But like I think it's okay. Okay. Now what do we want to do here? First thing that we want to do is grab out the mins and maxes. Yeah. So let's do that. Yeah, so for each column, we're either going to have like written examples of what's in the column. So like that might be like Anthropic, OpenAI, Google, or we're going to have numbers, right? And so then we want a range. So this is actually not just going to be the examples column, but the range. So we want to have the min maxes. So if the column, yeah, this is good. If the column has numeric data types, then the examples are going to be the range. I think this handles missing values inherently. Yeah, it defaults to true. Okay, so it defaults to skipping NAs or nulls, which is perfect. This is what we want, because otherwise that's going to cause like lots of problems. And also we like don't want to be using NAs here, so Copilot has helpfully suggested that we drop them and then we grab a unique value, so we don't like have just like the same one all over and over again. Like for instance, even though this is bugged, like we have a lot of Anthropic and OpenAI in this data set, and we probably want like diverse examples, right? And then we're going to join them up, and provided that the number of unique values within that column is larger than the number of maximal examples, we'll add like a ... at the end. This is actually like a super nice visual touch by Copilot, so we'll keep that as well. I like that a lot. And then we want to add in our row, and yes, this is pretty much perfect, I think. Yeah. Okay, we can also do this with f strings instead of throwing string around it, especially for like these here. Use f strings. We probably wouldn't for these, but this is fine. This works perfectly. And then we're going to return our table. Okay, cool. So we've got a function that's going to build our table that's like visualizing all the information we need to select the columns that we want. And the next thing to be aware of is like we want our users to be able to select these columns in like an easy and intuitive way. So like they should be able to select them by like typing 1. Oh, I've got a number wrong. Typing 1, or like for instance typing like we might want them to be able to like type like 1, 3, 7, or they should be able to type like a range of columns, like 2 to 6. And the reason for this is like we might have a data set. I don't know if we've got one in here. Let's have a little look. Like lots of the time when you're doing like benchmarks, they'll have like an overall score, but they'll have like some kind of like subcategories or like sub benchmarks. Where you have like multiple results which you want. So for instance here, like we've got the mean score and the best score, and we might decide that we actually want both of those. And it could be the case that we have data sets where they have like lots of columns that we want all at once. So in this case, I don't think we have like tons. Like there are data out there which I've used for similar projects, which will have like hundreds of columns which we want to select. And that's we don't want to type out like the names of the columns by hand or anything like that. And especially when the data set is like a fixed CSV, right? The data is not part of like some kind of ingestion pipeline. It's okay to hard code in the column references in terms of indexes. And so let's create a function that will pass our index list. And we're going to be taking in string from the user, and also we have the number of columns. And we're going to put out, yes, a list of integers. Okay. Yeah, that's exactly right. This is a good docstring. I'm going to delete this. This may well work, but it's not how I would have done it, and I want to talk through what we're doing online. So, first, we want to grab out our text, and we want to strip off any trailing spaces, and we want to make sure that like if we have nothing, it's not going to just break everything. So if text is like not present, we'll just set like an empty string, and then we will strip. Cool, and then we will just return. So if you don't have anything, we'll just return an empty list. Saves us some time and probably like a whole load of errors later. Okay, and then we want to grab yeah, so we don't want to have the same index twice. So we're going to have a set of just numbers. And from our text, we want to get out all of the distinct parts within the text. So we're going to have a list, which is going to be what we're returning for this function. I'm going to strip, so get rid of any trading spaces. For p in text.split, and we're going to be splitting on commas. So we're going to get out from this if p strip, yes. So we're going to get out from this like separate like one like within our list. We'll have like 1, 3, 6, 8, for instance. And this is getting rid of all of the spaces and things. So we've got like distinct list items, which are either single indices or ranges of indices. And then for p in parts, if we have a dash in p, we're going to split. So we're going to have like a and b as our starting and end values, and these are going to be on p.split. Yes, exactly like that. Okay, and then we'll convert these to like integers. So, yep, like that. And so now we've got a and b as our start and end integer within those parts which have a dash in. Now, because someone could do like a range backwards, let's grab out the low integer and the high integer by taking the minimum of those two and the maximum. Great. And then we want to make like a new list of the integers in between. So for k in range, and then we'll have low and high up to +1, and we'll say between 1 and our number of columns within that range, we will add them in. And this is a 0-based index. The reason that we're doing this is so that people can't like put in integers that are outside of the columns. So that's good. That's good and ideal. Otherwise, this is meant to be set back a bit. Yeah, there we go. So otherwise, if we don't have a dash in there, then we just got an integer. And so again, we'll do the same thing. We'll ensure that we are in the right range, and we'll convert to a 0-based index as well. Okay. Cool. And then we can return the sorted out. Yeah. Should be perfect. Okay, let's just add a bit of spacing. This is otherwise going to get a bit messy. Okay. Neat. I think this is good. Right. Okay. I'm going to give us a pause here because we're about halfway through the stream. In this pause, I'm going to fix my VS Code, and I encourage you all to take a breather, take a break, catch up with me if you aren't already caught up. What I'm going to do, for anyone who wants it, is I'm going to create a git ignore and get rid of all of this, because, yeah, I don't want I don't want, actually no, this should just be fine, and I don't want data in here either. Okay, actually don't even want, I don't want any of that. Okay, perfect. Right, I will commit my git ignore and my script. I'm not going to commit the data. You can grab it online. Although what I will do is I will put in the links in here from our data. So we've got that, and we've got that. Right, perfect. And what I am going to do is add a little README and I'm going to grab from our data. Yeah, okay. So I'm going to grab this citation and just pop it in this README. Awesome. Yes, okay. Simple data pipeline CLI tool for an MLH Global Hack Week stream using data kindly provided by Epoch AI. Nice, and I will actually throw the model data in as well to that as well. From they've probably got a license for that in particular. Actually, while we're taking a quick pause, we'll go and grab that. Make a new Chrome window. Epoch AI model. Yeah, this one. Oh, it's very bright, isn't it? Where is the? Somewhere in here, I'll have a license using this work. And we'll grab the citation. Perfect. Hello. Okay. Sure. Okay, perfect. Right. For anyone who wants to catch up, I'm gonna now commit all of this. Go on VS Code. Give me a commit message. Yeah, perfect. And we'll publish this branch, and I'm going to put it onto a public repository. And we'll open it up, and I'm going to drop the link to that in the comments. Okay, cool. All right. Cool. We're going to take a very quick break. I'm going to grab some water and fix my VS Code issues. So I will be back in 5 minutes. 5 minutes exactly. Yeah. Please do catch up if you're not already caught up. Take a breather, have a drink of water, and if you're having VS Code issues, you could fix them as well now. Okay, right. I'll be right back, everyone. Alright, hackers. Welcome back. Hope you enjoyed a quick break. I have replenished myself with more water and fixed all of the VS Code issues, I think. So we gave VS Code a little restart, and now, fingers crossed, everything's going to be great. We'll give it a little go. Yeah, looks like everything is fine. No weird bugs. So that's great. And I hope you all managed to grab either a copy of my code or update your own code. So we're all at the same place. Now, most recently, we managed to pass an index list and create a new table, which will make selecting our columns even easier, which is ideal for what we're going to do in a bit. And so, I'm completely in the wrong place in my notes. So I'm going to just swivel down a little bit until we're ready. Okay. Cool. Yes. Okay. One thing that we might want to do, especially, and I mentioned it earlier, when we're selecting our columns, doing it manually is a bit of a pain, but we can often spot, okay, if you want to pull in just like all of the metric columns, right, all of the numbers that matter, that are relevant to our model, this is like pretty easy to do because we can just filter based on our data types. And so we can use that as a heuristic. Okay. We can also like exclude like super obvious ID columns and stuff automatically. The things that which we'd kind of do with our brain, we can actually kind of like put these into practice as heuristics in a function. So we'll give that a go as well. So we're going to call this infer metric columns. And this is going to be taking in a data frame. But actually this is completely wrong. Thanks Copilot for that one. And we're going to have a set of columns that we'll exclude, right? And this is going to be a set of strings. And we're also going to have like a minimum fraction of our column. This is something that we can tune, which has to be numerical. And so I'm going to put that like 0.8. Basically what this is saying like 80% of the column has to be numbers for us to consider it a numerical column. We could probably go higher on this, but like I think this seems okay. Like we might have like a column of numbers where we have like some comments in some of the cells and things like that, but it's largely just numbers and we want to treat it that way. So yeah, this is going to be essentially like guessing which calls are metrics based on how many values are numbers and not numeric. No, sorry, and not null. Are numeric and not null. Yes. An apt description from Copilot. So we're gonna have an empty string, and we're just gonna loop through all of our columns. If C is going to exclude, so if the column that we're in is like being excluded intentionally, we'll just skip it. Otherwise, let's grab out the full column, and we will check if it's already the right data type, and then we'll just add it in if it's a numerical column. Otherwise, let's see what we're doing. No, we don't want to do any of that. That's not what we want. Okay, and actually we don't even want this. So we'll just rerun this ourselves. So otherwise, we're going to force it to be numeric. And we're going to do that on the column, on everything in the column, and we're going to just coerce all the errors. And then we will say, okay, what portion of these that are not missing, so it's a portion, so it's a mean, what portion of those, what fraction of those are actually numbers, and if it's bigger than the fraction that we just spoke about, we'll throw it on there, and then we'll return Perfect. Okay. Right. So this is like not magic, right? We could use an LLM or something like a little bit more intelligent if we wanted to, but like we're going to keep it simple for now. And you could like adapt this to take in the column name and like some of the column values and use an LLM if you wish. But for now, we're going to keep it nice and simple. And this is going to still allow us to like manually override this, like we're not going to be restricted to this. I'm just like looking at this error. I don't think this is. Oh, that needs to be lower back. There we go. There we go. Okay, right. Yeah, but this is not magic, but it's simple and it's efficient and it's going to save us a lot of time on these benchmark tables. The other thing we want to do is we want to add in a preview. And I think we're going to want to do this. Yeah, we don't want to do this with a function again. And so we'll just define a new function. We're going to call it long preview. And as normal, we're going to take in data frame, and this is going to give us a preview of like the selected columns, i.e. what we've picked out as the user as things which we're like saying, oh yes, these are the valuable columns, these are the ones that we actually care about, and so on. So we can kind of like check our work, and we can say how many of these that we actually want to throw out there. By default, I'm going to say 12, and we're not going to return a table, we're going to return a data frame. Okay, and this is going to be like super simple. It's just going to be a data frame with a model column, and within that also the metric columns. And we're going to copy this because otherwise we're creating like a referential data frame, and that means that every time we try to like edit stub, or if we edit the original data frame, it's gonna like cause weird problems. All right, and again, we're gonna grab out our model column. We'll go lowercase here. Value name is equal to value, yes. All right. Can I have the description of this? There we go. Okay, so we're taking what is originally a wide data frame and we're making it long. And we can put in our various different names and things here. We didn't keep value name. We wanted value name. Where did that go? Perfect. Okay. Yes, so we're pulling out and basically taking our wide, potentially wide data frame, and we're squishing it so it's long. And this is going to be more useful for us when we're collating all of our different data. So that's pretty good. And we're also going to create like a helper function. And at the moment, we're just getting to like a very long list of functions. Maybe in a minute, we'll like move these around and tidy them up a bit because it's kind of messy. We're going to create a function that takes a data frame and puts it into a rich table because we're doing that a lot at the moment, and it's kind of silly. And it would be helpful to have a function that is doing it for us straight from a data frame. Now, I believe this does exist in some versions of Rich, but I'm definitely not on the right version. Or like when I've been testing, I don't think that like the default version when you pip install with the other packages that we have works. But they're like, I think there is potentially like a new function within Rich that takes a data frame natively. Who knows? But I don't. So if someone is like a Rich pro, then please do correct me. But we'll just set up some defaults here. And we don't care about the rest. Just go for the defaults with them. And so for each column, we will add it, and we will fold it, and I don't care about the wrap. And then for each row, again, we will Yeah, that will do. Okay, so this is like, we've used some of this code before, which is like, if it looks familiar, it's because Copilot has just ripped it directly from where we used it earlier in the preview table. But yeah, we're going to use this and save ourselves some time. Cool. Okay, and now what we want is we want a new command. And we've already got a preview command, so I'm going to put it here. Like, this is like all in a bit of a jumbled mess, so we will move things. This is going to be a select command. I'm just going to allow the user to select what they want. Now I have this already typed out and it's quite long, so I'm going to copy and paste it in. If you want to like type this up by hand yourself, you can. But I'm just going to talk us through like what we've done here. And it should hopefully all just click into place. This is like mostly formatting and stuff, and I want to just save us some time. We've got about half an hour left, and I want to get onto the point where we're actually, at least actually looking at how we can match model names, because I think that's a super interesting problem. So we're reading in our CSV. Again, this is going to be like fairly similar to our preview, except we're reading in our CSV, we're doing a little bit of printing of summary of our data frame, and then we're allowing the user to select the model name column. Okay, and we spoke about how like we've got a couple of different ones of these, but for now we're just going to allow one, and they can either actually I think we're just allowing them to select the column number here. If we wanted to, we could allow them to select the model name as well, but we're not. We also allow the user to select a benchmark, split, or variant column, and this is particularly important when you have a data set where, for instance, I'm trying to think if we've got one in here. Have a little scroll through. So, oh yeah, here we go. This is good. Actually, do we have any? Yeah. Okay. So, like some data sets you'll have like this, have like the same exact model doing the data set, but with like different numbers of like shots. Or the data will be split, so you have like duplicate models, but there's an additional column that's a clarifier on like a variant, and this is like additional information which we need to handle, but like might cause us problems. Or equally, like we could have data which is like has multiple benchmarks. We mentioned this, that we could have like a wide data set which has like many sub benchmarks or components of benchmarks. But they could also have a long format, right? So they have like a benchmark column, and then within that column, it's got like, you know, if we had a benchmark which is teaching like English, maths, and science, right? You have a column which just says benchmark, and then the score could be like for an English or a maths or a science, and for each model, you'd probably have 3 rows. And this is going to really confuse our like data ingestion pipeline. So we need to have a way to handle that. Like, I don't actually think any of these like have this to like a major degree. I mean, this one does have shots, which is like a common thing which we would want to use this for. So that's immediately useful. And then we can allow the user to select the metric columns, and we're using our infer metric columns function, which we wrote earlier up here. Actually down there, because we've got everything in a jumble. All right, and where were we? Yep. So we confirm whether the whether we do it manually or whether it's done automatically using the function that we created, and then we can validate, print a summary, and we can also throw down some quick stats and this long preview that we just made as well, which is super nice. And we can also save optionally the selection as a JSON, which will allow us to use it later once we've selected the columns that we want in comparing and matching models, right? So this is actually really good. Now that's not ideal, so we're gonna have to fix that. And let's do that now. There are a few imports that are missing. I've just pulled up the list to check if we've got any other ones. I'm actually gonna put this up here. Import JSON. Are there any more that we need right now? No, I think we're good. I think that's the only one. Okay, perfect. Alright, we've got an error in here somewhere. That's just a remove line. Okay, that's not allowed. But, oh, where's the red coming from? Okay, perfect. All right. Cool. Cool. So the only other like major thing that we need to do is we need to like modify our build parser. We need to have a select commands. And again, this is just like a whole load of like very repetitive code. So I'm going to copy and paste this in, save some time. So I'm going to paste this in here. And right, so we've got our. Oh, I don't know why this is really fussy. Let's put this all onto one line. It's probably too long, but like I don't care. Okay, perfect. And I'm gonna get rid of that comma because it's neat. Okay, so we've got some additional arguments. That one we already have, so we don't need that. Oh, actually no, we will need it for this command because it's distinct. It's not shared because it's a subparser. That's my bad. We've got the name of the model column. So if we wanted to, we could just like throw in these directly instead of selecting them through the tool. And we can also edit some of our other features, like optionally showing the long preview, for example, or the number of rows, the fraction that we need for the like metric column matching, and whether we save it or not. Cool. So that should be like pretty much everything. The one thing that we do need to do is we need to go down to main and add another one of these in, and it's going to be arguments.command is equal to select. Okay. Now that should be everything. So let's give it a go, and then we'll tidy up the code. Right. So this bug is just still here. I've updated VS Code. What am I meant to do? I don't know. This doesn't happen in other like I've used anti-gravity. If you haven't used anti-gravity, it's super fun. Anti-gravity bit, which is just a fork of VS Code, and like it doesn't have these issues. Maybe it's just my VS Code installation. Maybe no one else has this. Who knows? Anyway, okay, right. So let's give this a go. We are going to run a file again, and we're going to put in the select command, and our input is going to be exactly the same. So it's arc-agi external CSV, and we're going to ask. Actually, we're not going to ask on benchmark. We don't care about that, but we are going to show the long preview, and we're going to save. I'm going to save it to. I'm going to save it to a new folder, which we're going to call selections, and we're going to just call it like the arc-agi .json. Fingers crossed. Okay, cool. Right, so this is the nice column catalog that we created, and so we can see the model version. We discussed this, right? We've got the name down here, so we can see, yep, fine, perhaps a bit more detailed, or at least, I don't know actually that it is more, it's a little more detailed, it's got a date and stuff, whatever. Although we do have the release dates here, so maybe it's better to match on this. We can have a try. We got all of our different columns, we've got the types and whatever. But we can now select the model name. Let's go for the actual name, so we're going to go for column 8. And do we want to auto-detect metric columns? Yes. Let's give it a go. Okay, so we had an error. No such file or directory. Interesting. Well, I mean, on the plus side, this looks like it's handled it well. Metric columns selected. It selected score twice. Do we have score twice in here? No. So why has it done that then? Interesting. Okay, so we've got some bugs. Let's fix them. We might not get into model name matching. That's okay. Yeah, we've got about like 10-15 minutes left. I'm going to be pleased if we have like a really nice column selection tool though, and especially if we can output the JSON nicely, that's going to be like, that's like a lot of the way there. It's a lot of the way there. So no worries on my front. No file or directory. It should create it if it doesn't have it, but admittedly, we might be missing that. I tell you what, let's restructure our code a little bit to make it neater, and in doing so, we'll probably spot issues that we're facing. I'm just like thinking about where I could come up. It's going to be here, right? So when we're saving it, this is the data that we're saving. We're grabbing the path. Oh, I see what we've got going on here. We want to take the path, yes, and we want to create it. So, yeah, this is perfect. Yeah. Okay, wait, this should fix it. This should fix it. Let's try again. I'm excited. I mean, this will fix some of it, not all of it. 8. Yes. Okay, so we still got like this weird, like, selecting score twice kind of issue. Okay, right, so, but we send the selections to here. Okay, cool. So we have no benchmark column, but we do have the name, we've got the inputs, we've got some notes that we put in here. And this is the second stage, right? This is this selection stage. And one of the things which actually we're going to get along to later is like these different benchmarks have like different values that their scores are out of. So this score to me looks like it's out of 1, although we'd probably have to check this by going to the source, right? And also like high might be good or high might be low. No, not low. High might be bad. High is not low. So for instance, like a good score on these benchmarks could be 1, or it could be 0, and we don't know that off the top of our heads, right? So we'd have to select this when we're going through our data. This is something which a model can't do for us, and this is part of what this like CLI tool can do. So I put a little note in. Again, this was in the code which we just kind of like pasted in quickly for the sake of time. Yeah, what I want to fix now though is this like ignore the duplication, but like this problem here where we're having multiple of the same column selected. So let's have a little look and debug. Okay. So it's definitely coming directly from here. Let's have a little look. I'm wondering if this is Copilot's doing. If in doubt, blame Copilot, right? So that's all good, and then we want to grab out the columns. We want to say, yep. Okay. So we're checking if it's numeric already. So in the case of score, it is, and then we're saying, hooray, we're adding it, and then we don't continue. We just in the same column, in the same loop, convert it to numeric, and then throw it in if it meets the fraction, right? And that's like bad and weird. So what we need in here is like continue, and then we're not going to have this like, duplication problem. What we are still going to have is this warning, where some selected metrics look non-numeric. I'm super intrigued by this because like training compute is afloat. and it's only got 13 non-null values in. So like training compute should just be numeric and nulls, which probably means that this warning is coming like exclusively from not handling nulls correctly. So like one thing we can do now is like let's preview the file again. And let's have a little look where we've got the head here. Let's have a look at our training compute. So yeah, it's just missing values. So what we're not doing very well is we're not handling our missing values well. And that's okay. I'm actually not going to bother dealing with this for now. Like it's just a warning. We'll handle that maybe in the next section. For now I want to make this like a little cleaner in terms of like our code layout. So yeah, let's move things around. I'm gonna just throw things in place where they should be. So we already have the command preview and the command select and the build parser together. So I'm gonna grab those out and I'm gonna just cut them. I'm gonna paste them in here. And let's add in some like headings, so like commands. Yep. Perfect. And we'll throw in here CLI setup. Yep, sure, right. That's already like a little neater. We know where some things are. This is a helper function. This is like a print function. This is did we move catalog? Where's catalog? It's like a build catalog. I'm thinking like all of our like table. Yeah, like our table functions should probably be together. So we've got like head table, we've got read. Like, let's move this up because this is just like a helper. Like yeah, sure, utilities, and then table builders, and this is like, really this is like a data frame, but it's kind of this is kind of like more like a table, if anything. So it's table builders, output builders. We'll call it output builders. This is like not a very good name for this section, but it's fine. Passing an index list. This is utility function. So this will go up here. And then this is a table, this is a table, blah, 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 blah. Infer, metric, columns. This is like not really, this is like cleaning inference utilities. Yeah, we'll go with inference utilities, cool. And so we can like add more to that later. I say later, we've got like 5 minutes left. So we'll see what we do in 5 minutes. We'll see what we do. What I'm gonna do is I'm gonna commit this. Oh, I didn't add a message. We'll get VS Code to do that for me. Good old Copilot. Yeah, nice. And we'll sync the changes up. Okay, have we got any questions? I've not been great at looking at the comments about that. What have we got? Enver, yeah. Can I copy in the chat? Also, I can't copy all of the code into the chat. It's just gonna be too long. It will like destroy the chat for everyone else, and it probably also will like cut it off. And also you're like not gonna be able to copy it from the chat. Like I really don't recommend. I would just like grab it from my GitHub. If you follow that link, even if you're not familiar with GitHub, you should just be able to like click download. And this is like a super easy one file project basically. So this should get you started. Okay, so we've got to a point where we're like neatly pulling out what we want. We actually don't want training compute flop because it's like not really a metric. Well, I mean, like it could be, depending on what you're trying to use this data for. For like my use case, I probably wouldn't want it. Again, what's wrong with my VS Code? Okay, but let's run this again and give it a go. So I'm going to enter the name, and I'm not going to auto detect this time. I'm going to select it myself. We'll test this function out now, and I just want the score. So let's put just the score in. Okay, cool. And that worked. So it just selected the score as the metrics. We've got 62 unique models, and we've got all of the model names here. This is looking super clean, way nicer than what we had previously. I'm very pleased, and we've got an updated selections tab as well. Okay, perfect. Right. So the next thing that we would want to do is we want to build a new command, and this command is going to be for matching our models across data sets. And this is where I think it gets like super interesting. This is where we'd be using this data as well. Yeah, I'm gonna ignore that. This is a little more complicated. So instead of just selecting columns, what we're now saying is we're taking these kind of like messy model names or model strings, and we're gonna match them up with canonical entries in this list here, right? And we want to do that consistently across all of our data sets, and we're going to have, therefore, a long export, either in CSV or like some other format, which we can use for modeling, which has the model name, which matches across the scores and the benchmark. So we could do this in a few ways, and I don't think we're really going to have time to put this into practice. So I'm just going to like describe some ways that we can do it, and this is like an extension for you all to do as homework. But hopefully you've enjoyed like building your own CLI tool for working with data, and learning a little bit more, and also like seeing some really cool data that is like very useful and very interesting, right? I think like Gen AI is like very important at the moment, and being able to evaluate it rigorously is super important too. So I love this data. I love Epoch AI and what they do. I recommend checking them out. But yeah, we've kind of dipped our toes into that land. But like, there's a few different ways that we could like match data, and so I'm going to say like new feature idea, canonical model name, like model name matching, and building a canonical model list. And within this, what I would suggest doing is like some kind of like multi-pass matching. So this would look like match exactly on the strings that we have on model names in columns as they are, and then like normalize, e.g. lowercase, yes, and try again. And then I would suggest using like a fuzzy match. And what we could do here is we could take out the top K matches with their scores, and we could use this for fast manual resolution. And then what we probably would also want to do once we've done a fuzzy match and then use that. So I could envisage this as being like a long list of like, oh, these ones which haven't been matched, but these are the top suggestions and their scores. Do you accept the top suggestion? And you could just very quickly scan through, go, yep, I accept all of these. And then we could build a canonical model list using this fuzzy match, the above matching, right? And then we can use that on future data sets as well. Okay, and they're going to be other data sets that use like the same names and stuff. So this is going to be like super scalable, super efficient, and like ultimately what we'd build like an alias kind of like cache, which is global across all benchmarks. And this would be great. Yeah, we could use the selections in here. This is kind of the reason that we did this, to like decide on how to match, right? So we'd use the model name column that we've selected, and then we'd pull through the columns that we want from the metrics, and also we'd handle the benchmark columns explicitly as well, right? So the benchmark was split. Cool. Well, we're pretty much out of time, but I hope you've all enjoyed this stream. I've certainly had fun. And despite our like weird VS Code issues, I hope you've like felt like we've got some kind of like satisfying tools out here with some pretty colors and some really like intuitive ideas on like what to do next if you want to kind of continue this project yourself. I don't know how like well this syncs up with like what the other streams the coaches have been doing, or even the feature challenges that we have. I know there's some really cool ones there, but I think it's a fun idea. Yeah, if you're looking for a project to build in your own time, it's a good one. It's a good one. Okay, I'm gonna leave us there. I will actually just commit the last of this. I think it's just this that I've updated, right? Yeah. Okay. I'm also going to commit the selections, the updated selections as well, because I think that's already tracked. So you can see it, and you can try this with like any of the other data sets in here, and it will work. Which I think is again super satisfying that we built a tool which is agnostic to the data that we're using. Yeah. With that, I'll kind of wrap up. I'm always looking for feedback, so please do give me feedback on this stream, what you'd like to see in future streams, anything which you really loved. It's always valuable. I'll pop a little link in the chat. So it's mlh.link/GHW feedback. And if you haven't checked in, if you didn't check in at the start, please do check in. You get bonus swag and points, which are the best, of course. Okay, thank you very much, everyone, for coming. I'm glad to see that you've all enjoyed it in the chat. I do think it's a cool project. And I think like CLI tools are like really underrated, especially I'm a bit of a data scientist, so like these kind of things are super useful for me when I'm working with data. So definitely give it a go. Build your own tool and use it. Use it for more data science and more data analytics projects. I think it's a very impressive thing to have on your portfolio as well. Okay, thank you very much, everyone. I've been Quinn. This has been fun. I'll see you all later. Actually, before I hop off, I will say let's check out what the next stream is, because you should go to it. It will be super fun as well. What have we got? Okay, in 2 hours, we've got a data to dashboard stream. I don't know who's running this, but it looks interesting. Data is only useful when it's visible. This session follows a journey from raw data sets to a polished dashboard. Information is clean, structured, and transformed into meaningful visuals. So if you want to do something like what we've done a little bit, but more cleaning, more structuring for the purpose of visuals and less for collating large data sets from lots of different sources, this is a really cool tool. Looks like it will be a multi-pod stream, so very insightful. Yeah, that's in 2 hours from now, so that's 11 p.m. GMT, that's where I am, or 6 p.m. Eastern time, and I want to say like 3:30 a.m. IST. So maybe go to sleep if you're over in India or really anywhere. Like, I mean, probably I'm going to be asleep by 11 p.m. So anywhere kind of east of Europe, definitely be asleep. But yeah, thank you very much for coming, everyone, and I will see you later. All right, bye-bye.